Hello all, I'm Daniel Thornton. Today I will be talking a bit about the Paketo Buildpacks project. Just a little bit about me. For the past couple years, I've worked for VMware on the Cloud Foundry Buildpacks, as well as this new Paketo Buildpacks project. And I'd like to talk with you today about some of the technical and ideological changes that have led to this project. So, what is the Paketo Buildpacks project? A simple definition would be it's a collection of cloud-native build packs to provide support for the most popular language runtimes. Here we have Java, Node, Go, Nginx, .NET Core, and PHP. And for each of these, we have an implementation you can go and use right now. And you might look at this definition and say, what? We just defined build packs in terms of other build packs. And you are right, we did. But I'm hoping throughout this talk, I can transfer some of this context around what build packs are, what cloud native build packs are, so that at the end, you walk out of here understanding what a Paketo build pack is and how to use one. So to give some understanding about what Paketo build packs are, let's talk about the problems that they solve. So the first of these is transforming application code into images. On any Kubernetes system, you're going to have to translate your source code into this application image in order to get it to run. This is true for vanilla Kubernetes, and this problem needs to be solved for Cloud Foundry on Kubernetes as well. If you want to see a push your app, we need to convert it to an image at some point. So let's talk a little bit about what the app image looks like. And on the left here, we have a couple of squares. Each of these represents a layer in an app image. And the sum of all of these layers is going to give us a file system that contains all of the bits we need to run our application. These artifacts have become the standard for building software over the past couple years. They're self-contained, immutable. They run on any container runtime, and they're extremely easy to distribute. All these factors make this a great way to ship your code, and one of the reasons why Kubernetes consumes them. So how do we make application images? Well, a first and easy step is writing a Dockerfile. All that I would have to do if I had an app is write a Dockerfile that loads my app and its dependencies in and run docker build. And this would give me an app image. So let's take a quick look here at a very, very simple Dockerfile, okay, just to get an idea about what they can do. So walking through here, we have from node current slim. So we're building on top of an existing image. We set the working directory, copy a package JSON file from our local host computer, and then run npm install. Okay, so this ability to run arbitrary commands in a Docker image and add all this configuration means that they're extremely flexible artifacts. If I write a Docker file, it can do almost anything. And it also gives us these precise and atomic tools to control exactly the bits that go into our image, which is great. I don't want extra dependencies hanging around in my image. The only thing that that does is add to the potential surface area that an attacker could exploit, right? So Dockerfiles have some quite good aspects. They are easy to get up and running with. They give you extremely precise control over the bits that go into your app image. But let's look at another example here. So on the left, we have a snippet from the official Python image from Docker Hub. And here we have the first 60-ish lines of a 112-line run command. And if you squint kind of hard, you can see that we're installing some OS packages. That's part of what we're doing here. And this addition and complexity is a result of having these atomic tools. If I want to build something up that has complicated behavior, what I'm going to need to do is use these tools extensively. And that's what we see here. And this complexity that results in building an image with these small tools is vulnerabilities, right? So in the Python Docker image example, I was downloading some OS packages. As soon as something goes into my Docker image, I'm responsible for keeping that dependency up to date. If there are CVEs, they need to be patched. I need to rebuild this app image using my Docker file. And so here we have a nice graphic provided by the folks at SNCC that shows us some OS vulnerabilities in popular Docker images. So these are vulnerabilities in that OS layer that probably could be fixed if you rebuilt your image. And so Dockerfiles have some really strong positives and some strong negatives. They give us these precise tools, but just the burden of managing all of these tools gives us quite a bit of technical debt. And if we don't keep up with that debt, our app images are vulnerable. So the cost for this solution, when you have thousands of apps, hundreds of Docker images, it's too high. And so there must be another way for us to do this. And so we want to do this without Dockerfiles. And the solution is the Cloud Native Buildpacks project. And so what this is a CNCF project with contributions from Google, Heroku, Microsoft, VMware, many others. And what it seeks to do is to build application images, and they provide us with this tool, the Pack CLI, and they also give us a specification for any build packs we write to provide dependencies. They must adhere to these rules. And this is a great way to avoid managing a fleet of Docker files. Some additional benefits of using the tooling that the Cloud Native Buildpacks provide are reproducible builds. They leverage ABI compatibility in some of the stacks they provide to enable safe and efficient OS patching. So this is a really important point. If you have a libSSL vulnerability, you don't have to rebuild your entire application. You should just be able to swap out those OS level packages at the very bottom. Optimizing rebuilds is one of them. Enable imaging auditing. There's a bunch of other features that come out of this project. I would recommend you check them out. And here's a link that'll be distributed with this deck. Okay, so the Cloud Native Buildpacks project. We have a little diagram here about what exactly this does. It takes source, the Buildpack specification, uses the Pack CLI, and we get our app image. Okay, so this is exactly where Paketo Buildpacks fit in. They are build packs that follow this specification and give us some extremely beneficial behavior. And so let's kick things off here and give a quick demonstration. We're going to use two Paketo Buildpacks, the Node Engine Buildpack and the NPM Buildpack, and we're going to produce an app image that has these two dependencies inside of it. Okay, so hop on over into a terminal session. Okay, so here I am. I am sitting in a directory that contains an NPM app, and I'm sitting at the root. So I have a server.js file, a package.json file for all my NPM dependencies, and building this is as simple as running Okay, awesome. So I'm running a pack build. Here I've just told pack what I want the name of my image to be, and I've also specified what build packs I want to use. And so if we just kind of examine the output that's being spit out here, we can see that we are using two build packs that passed detection. They are the Node Engine build pack and the NPM build pack. And so let's kind of walk through this output that we get when building. So we can see here that the Node Engine build pack runs. It selects a version of Node that your application specifies or chooses one if it does not. Installs this version of Node and configures the environment to set up some environment variables so your application can actually use Node at runtime. And it writes a profile descript. We won't go into the details of that. Okay, and next we have up the NPM build pack, and this uses NPM. It runs an NPM CI to install all of the node modules that this application requires and were specified in the package JSON file. And we kind of see that it follows some similar behavior, and at the end we get an output image. Oops. And here we go. Here's our CF demo application. It was successfully built. Okay, that's awesome. So one of the kind of interesting little tidbits that we can do with this is show how these builds are, we can rebuild our application in an extremely performant way. And so all I'm going to do is just edit this file a little bit. And let's say we add some additional details to our greeting page. Awesome. So now I'm going to rebuild the same application, and let's kind of examine this output again and see what happens. So once again, we're going to see that oh, here we go. So once again, we see that we're going to be using the same build packs as we did last time. Oh, but this building step is quite different, right? All of a sudden we're reusing some cached layers despite our application changing, right? So Pack was able to say, okay, all right, node 10 20.1, you built your image with that last time. I don't need to go through the process of re-downloading this dependency and re-adding it to your app image, right? Similarly, we have the NPM build pack is able to reuse all of the cached NPM modules. All right, that's pretty awesome. And this behavior is intelligent. If you change your NPM modules or your package JSON file, it will end up re-downloading them. There's been a change. But okay, let's just briefly hop back over to our slides. Okay, so we've seen a little bit about how Paketo Buildpacks interact with the pack CLI to provide specific dependencies to our application and to inevitably build an app image. So one of the things that we saw in the previous build was this usage of two build packs to provide both Node and NPM. And this is quite opposite what the Cloud Foundry Buildpack used to do. There's a reason for this. The old Cloud Foundry Buildpack was responsible for just too much stuff. Installing Node, NPM, Yarn, selecting the correct install process to provide Node modules. A lot going on in here. And the end result is that it made it a little bit difficult to maintain, but definitely more difficult to contribute to. If I'm a developer and the only thing that I know how to work with is Yarn applications, I don't want to touch any code that has to do with an NPM install. So the Paketo Buildpacks project, it redefines the relationship between build packs and the dependencies that they install. So here we have the old Node.js build pack, And in order to achieve similar functionality, the Paketo Buildpacks have been broken up into these 3 modular distinct pieces that do one job and do it well. So they have a single responsibility. Node Engine should install Node. NPM will install your node modules. Yarn install will also install your node modules using a different tool. And these are composable elements, meaning that if my app requires Node, I should be able to get it in there, right? I should be able to have the Node Engine Buildpack detect and add Node to my app. This refactor from Cloud Foundry to Paketo has made each of these build packs have well-defined boundaries and made them more maintainable. And again, with this maintainability and simplicity, we get additional ease of understanding and contribution from external developers, right? Okay, so we've seen a little bit about how we can build an application using Pack, using 2 Paketo Buildpacks, but let's kind of dive into the details of this singular responsibility and our app image. So if I jump back over to my terminal, we're going to use a tool called Dive. It's quite nice. And it's going to give us some additional information about what is in our final app image. Okay, so here we go. All right, and over here on the left, we have a pane that gives us the layers in our application image. So remember, the app, the dependencies, and the underlying OS. The ordering here is slightly flipped from what we saw in the slides earlier. This first layer is the base layer, and everything on top of it is further up, right? So if we kind of search through this, let's take a look at this 67 megabyte layer. Okay, so this red highlighting shows the new additions that this layer adds to our application image. And if we just inspect what that is, we can see that, oh, sorry, went too far. We can see that this is our Node Engine build pack, and it provides this binary node, exactly what we wanted. So we kind of have this nice connection between a build pack and then these layers that it provides directly into our image. Similarly, we can see the same relationship for the NPM build pack. Here it provides the node modules. And here's some additional environment variables we have, but here are all of the node modules that our application required. Okay, so back to some slides. So one of the problems that Paketo Buildpacks kind of solved was this refactoring, the breakdown of the monolithic Cloud Foundry Buildpacks into these pieces that are easier to understand. So from a technical point of view, this refactoring into composable elements makes our build packs easier for external developers or people who are interested in this project to figure out what's going on in them, to figure out how to write one. But there's also this aspect of how the Cloud Foundry build packs were written and maintained that made it a little bit difficult if you were an external developer to jump in and contribute and have full view of the decisions that are being made and what was happening in this project. And so we've tried to change this culture in Paketo Buildpacks. So we have some open source governance rules. You can check these out. They're in an RFCs repo in the Paketo Buildpacks org. But this follows kind of a traditional open source model where we have contributors and maintainers. And the second piece is that we've largely moved our work to use the PR process, right? We're no longer just pushing up commits to master. And as a result, this adds an additional layer of visibility for work that's going on in the Buildpacks community and additional discussion that can happen on any PR, right? Previously, our philosophy for this, at least on the CloudFoundry Buildpacks side, was that you would be given some notifications about when we were working on stuff, but true involvement in the process was difficult. And kind of the last large change that this project has spurred has been migrating most of our pipelines off of this kind of concourse, which is a tool that we used to use, to the new option of GitHub Actions. So they're sitting right in these repositories, easily accessible. You can look at the status of your PRs. And we also have all of these pipelines that are set up to release build packs as soon as they meet a certain threshold or maintainers agree that it's time to release, okay? Okay, so here we have some changes. So we've made build packs more approachable. That's kind of this other piece of Paketo. We've done it both on a technical level and also on the way that we interact with other devs. So we hope that these changes will have significant impact and we can kind of break down this walled garden culture that made it a little bit more difficult for people to contribute to the Cloud Foundry Buildpacks. Okay, well, thank you. Here's some additional materials in case you're looking to get started, have some additional information. Please visit the Paketo website, and thank you for the CFF for helping us set that up. There's some guides about walking through sample applications and how to write a build pack if you're interested. You can also check out all of our build packs that are currently available right here at the Paketo Buildpacks org. We have a samples repo to give you some idea of applications that you can build right now and how they relate to applications that you have running. And finally, we have a Slack instance. We'd love it if you stopped by and said hello, and hope we can answer any questions. All right, thank you very much. It's been a pleasure presenting.